application, the fully automatic laser cutting and shaping of diamonds. We call it DaVinci Diamond Factory. I will explain you in the next minutes how it works. Maybe just one word to the company. So Synova is a Swiss company. We exist now since 24 years, and we entered in the diamond industry about 10 years ago. So before, our applications were in the semiconductor industry and in metal industry. Okay, so what we can say is that we have made real the dream of automatic diamond production with this technology, where we can now manufacture diamonds virtually completely from rough to polish in one single process, in one single machine. So this is the machine. It's a very compact machine. The basic machine has a size of a pallet, 1.2 meter times 80 centimeter. Then on the side, we see here the laser unit and the water system, because we have a different technology than conventional laser. We call it laser microjet. It's a water jet guided laser that has been invented many years ago for a medical application. So the machine consists of a very accurate 5-axis 3D machine and is including our technology. So the typical manufacturing flow of diamonds is presented here in roughly in a certain number of steps. In reality, there are more steps than here presented, but it shows you roughly the various steps between the rough stone that has to undergo first planning up to the finished stone that can be mounted into a jewel. Now, with DaVinci, we reduce the number of steps strongly. And from the planning, we have just one step before the shaping, which is the sewing of the table. And then we cut and shape the diamond in one step without interruption, and until we have all the 57 facets of a round brilliant shaped. Then you see the black color, which is a carbon layer, and which has to be removed in a final polishing step. So how does it work? The first step, we have a CAM software, and so it means after the table sewing, which can also be done on this machine, the stone is scanned and planned as usual in a planning machine, planning system. Afterwards, the data then are going through our proprietary CAM software, so that all the facets are defined for the machine, so that the machine knows the cutting order to cut all the 57 facets in a specific order. Then step 2, the stone is mounted on a holder, a specific holder that we have designed especially for our machine, so that we can access to all the facets that have to be cut with the machine. And in this separate mounting station, which is part of the system that we deliver to our customers, the stone is mounted with cameras, and in a way that the machine finds the rough position very quickly of the diamond, of the rough diamond. Then after, the stone has also marking lines, gets marking lines in the planning tool, and then the stone with the holder is mounted into the machine by hand for the time being. And the machine has a built-in vision system, and so finds exactly the position in X, Y, and Z of the stone. Step 4, we import the data that went through the CAM software, and the CAM software generates an NC file that the machine can read, so in a machine format. as you can see here. These are typically the G codes in 5 axes. You can also load, by the way, data of the diamond in using standard diamond proportion parameters. So if you want, you don't need absolutely a planning system. You can do this in this way, which is not, of course, the optimum way. Then step 5, the actual shaping process starts. And using our technology, you can see it here quite well. You see here this red line. This is our water jet guiding the laser beam. It's a green laser. However, the water jet appears red. This is another physical effect. And then the machine is cutting one facet after the next in a given order. And to explain it to you better, I have here a video that should show you.
Synova, inventor of the unique water jet laser, presents a revolutionary system for shaping diamonds, DaVinci Diamond Factory. It transforms rough diamonds into brilliant cut diamonds in a single, fully automated process. In preparation for the laser process, the rough diamond is scanned and planned by an external planning device. Stone parameters are then transferred to the DaVinci system. The diamond factory consists of a precision CNC machine with a high-power green laser, a compact water pump, and an ultra-pure water unit. The DaVinci system also includes a CAM software that reads the planning files and defines the facet cutting order for optimum yield. Meanwhile, the planned rough diamond is glued with the table side down onto a flat holder and clamped inside the machine. The visual alignment process follows to perfectly adjust the stone in the machine. The 5-axis system positions the diamond for the shaping operation and starts the fully automated process. The process time per facet averages from 1 to 8 minutes, depending on the size of the diamond. The laser operation is supervised by an integrated breakthrough sensor which recognizes when a cut is finished and automatically triggers facet changing. The DaVinci waterjet laser system will cut up to 57 facets of the round brilliant in one go. The automated workflow of the DaVinci machine needs no permanent time-consuming quality checks while shaping a perfectly symmetrical diamond. An additional benefit is the cooling effect of the water jet during ablation. Diamond damages, even in stress stones, can thus be significantly reduced. The result: a perfectly shaped diamond with 57 facets. In addition, customers also benefit from increased value due to reusable cut-off diamond chips. After completion of the DaVinci process, a final polishing step will bring out the desired shine and add the finishing touch. The DaVinci Diamond Factory, your automated shaping solution for round brilliance and fancy shapes. For more information, visit us at www.synova.ch.
Okay, so I have a few more slides. So the final result, as you have seen before, is a black colored diamond. So that's the carbon layer generated by the laser that has to be removed afterwards. In the polishing process, that is quite fast. In about 1 to 2 hours, you have finished the stone. And as it is mentioned here, and then you have as a final result the finished polished diamond. So the features of the system are the following. As you have seen, the input is the rough diamond with a flat table. The cutting time is typically 1 hour and 15 minutes for a 1 carat polished round brilliant stone based on a typical 40% yield. Cut accuracy of the machine is less than 5 microns, which is impossible, as you can imagine, manually. The typical rough size ranges between 0.25 carats and 50 carats. There's theoretically no upper limit of the stone size. Cut grade is typical triple X because of the accuracy of the 5-axis machine. As shapes, we can cut round brilliant, fancy, virtually any shape, even concave shapes are possible with this technology. The surface finish is very smooth. The RA, average roughness, is typically around 200 nanometer. And the system is integrated with, or can be integrated with conventional diamond planning systems. So, and as you have seen, there's one shot post smoothing necessary to finish the diamond after the laser shaping. So here you see the benefits of this technology. It's the first fully automatic laser faceting process. It's very simple to use. You can learn it in 1 week. If you compare with conventional polishing, manual polishing, and you know that it takes a lot of time to learn this. We have strongly reduced the manufacturing time. It's now done in a few hours instead of weeks that are needed to polish a diamond. And of course, pipeline that what reduces the cost for inventory and interests. The yield is much higher and more constant with this technology. We can extract an increased value from the rough stone because we maintain the cut-off chips that can be reused afterwards, that have a real value. The system can be integrated in third parties, blockchain and traceability systems without any problem. And there's also a very high flexibility, manufacturing flexibility in terms of location. So this machine can really be installed and used everywhere in the world. Yeah, they have also seen that there's a strongly reduced footprint of the machine. Almost, we can say, a whole diamond factory in one machine. So as a conclusion, we have here presented a true disruptive technology for diamond manufacturing. And I can also only repeat what has been said at the last diamond conference in Dubai. This technology will change the industry. Thank you very much for your attention.